Hi everyone, Mrs. Belo here. In this video I'm going to be going over the Chapter 2 notes on lab equipment and measuring. So make sure that you are bringing a calculator with you every day. We are going to be using it a lot moving forward. Before we get to math, calculations, measurements, let's talk about lab equipment. So you're going to be doing a variety of different labs in here, and it's really important to know what each piece of lab equipment is. So when you are reading instructions for a lab, you know what to do. So first we have two tools here that we use to measure liquids typically. The first one on the left we have here is a beaker. Beakers are usually used to hold liquids. We don't use these to make accurate measurements. It's just a place to store them. Versus this one on the right, this is a graduated cylinder. And this is used to make accurate measurements. Towards the end of this video, I do go over how to make accurate measurements with this piece of equipment. Next, we have what we call an Erlenmeyer flask. This is used to mix liquids, and because of its shape, when you're mixing things in it, it prevents liquid from spilling out. On the right here, we have test tubes. And these are used to hold a small amount of liquid. Typically, we are going to use these in class to mix a small amount of liquid. You can also heat things up in this as well. Next, we have what we call a pipette. A pipette is used to add a small amount of liquid to something like maybe this beaker, or I'm sorry, maybe these test tubes, or maybe when you're trying to get a really accurate measurement in a graduated cylinder. Next, we have what's called a weighboat. This is used to measure small amounts of solid substances, and we use this on our electronic balance. So typically you would take this weighboat, you would put it on the electronic balance, and you would hit the tare or 0 button, and then you would add your solid to it. That way it doesn't spill all over the place on the electronic balance itself. So this is an electronic balance, as I just said, and we use it to measure small amounts of solids, and it's going to be in grams. And some electronic balances have different varying degrees as far as how accurate they are. Next, we have a spatula. So I have these ones, but typically I actually use a plastic version of this just because they're disposable. But these are used to scoop a small amount of solid, such as if you're trying to put that small amount of solid from like a bottle or a beaker onto your weighboat. So that's how you would use all three of these things together. Next, we have what's called a ring stand. And this, we attach various things to it. Usually in my class, I have this clamp tool that you can attach to it, and then you can attach these really large, they look like large test tubes to it. And you can also attach something that can, be used for heating something up as well. So this can be used in a variety of ways. Next, we have what's called a watch glass. Technically, this is used to evaporate things. So you take a piece of filter paper that you've poured a liquid on that has some type of substance in it that you want, and you put that on here, the piece of paper, and you let it dry. You let it evaporate, and then your substance will be left behind that you want to collect. Next, you've seen this in my demonstration. This is a Bunsen burner. This is, of course, used to heat things up. And then to light the Bunsen burner, we have what's called a striker. It's used to light the Bunsen burner. And then we have these things here. We typically use this one in class. This is called a well plate. It's kind of like a test tube in that it's used to mix small amounts of liquids to see if there is a chemical reaction. Now let's talk about measurements. So again, in here we use graduated cylinders a lot, and it's really important that you know how to measure with them correctly. A lot of students in lab, they'll just estimate things. You really want to make sure you're getting the most accurate measurement possible. Otherwise, that can affect your data. So these are going to be in milliliters, all of the ones that we use in class. And typically the ones we use, you can go at least 1 decimal places. Some of them you can go 2. It depends on the graduated cylinder. And you always want to make sure you never pick up the graduated cylinder. You always want to leave it on the table, and you want to get down to eye level. And you're going to measure from what we call the bottom of the meniscus. So most liquids, when they're inside the graduated cylinder, they'll create this kind of shape. And you want to make sure you're measuring from the bottom of that. The bottom of that is where you want to make your measurement from. So I have some practice problems here. Here's an example. Let me do this one first, and then you can try the other 3. So for this graduated cylinder, let's look at the units first. So here we have 10, and then here we have 20. So that means this halfway point must be 15. So that means each one of these lines is 1 milliliter. So this is 11, 12, 13, 14, that would be 15. So I know that this the meniscus, this right here, where I'm making my measurement, I can see that it is in between 12 and 13. And so remember, graduated cylinders, it starts with 0 at the bottom and then it goes up. So I can see that this most certainly is 12, okay, like they have here. That we can say with certainty. We know that that is 12 milliliters. This right here would be the estimated value. This is like, you know, what we're eyeballing. So we can go at least 1 decimal of uncertainty. So we can go, excuse me, what is this one? I'm going to say 0.5 because it looks like it's halfway between 12 and 13. So for something like this in between here, you could have something like 12.1, 12.2, 12.3, etc. You cannot go another decimal place, okay? That's impossible because this instrument does not go to that level of accuracy. So based on that, pause the video and see if you can do these 3 on your own. Okay, now I'm going to go over the answer to these 3. So for number 1 here is 20 and here is 30. So this must be 35. And we can see the meniscus is above 35. So we know for sure this is 35, okay? I'm sorry, 25, my goodness, 25. So that means that this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So it's just like the other one we were just looking at. And we can see that, again, it most certainly is 25, but then I can go 1 decimal of uncertainty. So you could have said definitely anything below 0.5 I think would be acceptable. So for this, I would say maybe about a 0.1, or I would say a 0.2. I think that would be acceptable. For this, let me look at it again. I'm going to say 0.1, and this would be milliliters. Definitely, I would say this is below a 0.5 because it's definitely below that halfway point in between those 2 measurements. So yeah, so if you were like, if I was like evaluating you or grading you on something, this would be an acceptable answer. This would be an acceptable answer. This would be an acceptable answer. And I probably would accept this as well. That would be the highest I would go. If you want anything outside of that or above that, then I wouldn't accept that. Next, for this one, so this is 35 and this is 40. So this has to be 36, 37, 38, 39, 40. So again, each one is 1 milliliter. So this it's definitely in between 36 and 37. So it definitely has to be 36. And then I can go 1 decimal of uncertainty. So it definitely looks like it's above 0.5. So I would say anything 0.5 or higher would be acceptable. So I would say 0.5, 0.6, 0.7, 0.8, maybe even 0.9. I would accept that as an answer. I would say this is closer to like a 0.7 milliliters. Okay. The last one. So here we have this time, we have 5 and 6. So this must be 5.5. So that means that each of these is, so this would be 5.5. This would be 5.1, 2, 3, 4, and 5. So each one is 0.1 milliliters. So that means that this one right here has to be 5.4. And I could see the line, it's not at 5.5 yet, it's above 5.4. So I can say with certainty, this is 5.4. And so this time we can go 1 more degree, or we can go 1 more decimal, because this instrument is a little bit more precise. So it has more decimals in it. So we can go 1 more degree of uncertainty. So this would be, I would say, definitely above 0.5. So I would say 5.45 or higher. So 4.45, 46, 7, 8. I would probably say 9 for this, and then milliliters. Again, it's really important to make sure you're looking at how you're measuring with the graduated cylinder. When we are doing labs in this class, these two and this one, those are the most common types of graduated cylinders we will use.